Alright, welcome to Advanced Segments Formed by Chords. Now, in this very first example, what we want to do is we want to find the length of CB. And as you'll notice, CB is this entire line, and we're actually going to have to first find the value of x. Now, as I look at this problem, I noticed something interesting. I actually noticed that this line, let me go ahead and put this in a different color, this line from E all the way to D actually goes through the center. Now, why is that important? Well, it means that this line right here is actually a radius. Well, what's important about that? No matter where we draw a radius in a circle, it always has to be the same length. So when I look at this, I see this radius from A to E is also going to have to be the same length as from A to D. Now, what's interesting about this is that we actually don't know this line right here, AF. And so if there's anything that makes this problem difficult, it's finding that length first. Now, how can I tackle this? Well, I know that my entire radius, so once again switching back, I know that my radius is 9 inches long, implying that this also has to be 9 inches long. And so we can say this, 9 minus this piece that I know right there, 4, must equal 5. And so this missing piece that I have here in the purple must actually be 5 inches. Now, why was that important? Well, we know that whenever we have lines inside the circle, chords and diameters, we're always going to do the piece times the piece. So in essence, I now need to say, hey, this is 9, this is 5, and what is 9 plus 5? Well, 9 plus 5 would actually give me a total length of 14 inches. And so now I can go ahead and start working with my formula to solve for this line CB. So here's what we'll say. We'll set up a statement, and we'll say that E all the way to, it's kind of hard to see there, F, but EF, that piece, times this other piece, which would be FD, because remember, when it's lines inside a circle, it's a piece times a piece, will equal CF times FB. And now at this point we can actually go ahead and start filling things in. So I see that E all the way to F, that was the 14 that I just found, times FD, which is right there, was 4, will have to be equal to, let's see, CF, which is right there, 6.8 times, and then the remainder of that, 3x. Now, I would highly encourage you to grab your calculator. We know that 14 times 4 would go ahead and give us 56 equals, and next we'd go ahead and do this 6.8 times 3, and 6.8 times 3 would be 20.4x. Well, now we're one step away. We are going to divide both sides by the number in front of x, which would be that 20.4, divide by 20.4, and it turns out that 56 divided by 20.4 would actually give us 2.7, and that 4 would actually round up to a 5. And okay, so we know that the value of x is 2.75. Now here's where a lot of students make a mistake, in that they stop rather than finishing the problem, because our original question is asking us to find CB. Let me go ahead and switch up to a different color here. And we know that once again, let's see, C to F, that's going to be 6.8. And in order to combine segments, we're actually adding them. So we'll write 6.8 plus, and y'all notice how we have this line right here, FB was a 3x. Well, rather than 3x, let's write 3 parentheses, and here's where we're going to plug in our value of x that we just found, the 2.75. And so I'm just going to go ahead and multiply 3 times 2.75, which gives me in fact 8.25. And now if I'll do 6.8 plus 8.25, so plus 6.8, we wind up getting this. We wind up getting 15.05 is going to be the length of CB. All right. Let's go ahead and move on to example 2. And now, by the way, I would encourage you to pause this video and finish writing the notes if you still need time. Okay, now as we look at example 2 is asking us to actually find the length of CB. And once again, we'll notice CB is very similar to the previous problem, and that it's this segment right there. However, one slight difference, we'll actually know that CB has been bisected, and it's actually going to be two equal parts. So we have a 2x and a 2x. Now, this will be the exact same as our previous problem, with just a little bit of a twist on the algebra. Okay, so where can we start this? Well, the first thing that we want to notice is that this line from E to A actually goes from the center to the edge, and much like our last video, that actually creates a radius. Now, what do we know from our very first example? Wherever we draw a radius, they will always be the same. And so I know that A to E must also be the same length as from A to D. So if A to E is 11.4, A to D must also be 11.4, which would then allow us to find this missing line right here, AF. So what we would say is this. We see our radius is 11.4, and then we see this other piece right here is 5.3. And once again, to find a missing section, of course, we have to subtract. Now, like I said, always use your calculator, and we know that 11.3 minus, 11.4 minus 5.3 would give us 6.1. And notice I drew it in a different color just so you can see, hey, that right there is 6.1, and that's what we're trying to find. Well, once again, why is that necessary? Because we know that whenever we are dealing with line segments that are inside the circle, chords and diameters, we're always going to have to take and do a piece times a piece, which implies we need to know how long is this piece overall. And in order to find that, of course, we'll have to take this portion 11.4 and add that, of course, with the 6.1. So I reached back for my calculator, and I know that 11.4 plus 6.1 would in fact give me 17.5. And now I actually have enough information to go ahead and write my statement. So here's what we'll say first. We'll say that this piece, EF, times this other piece of the same line, FD, must equal, and then I go back over here to where I have this in teal. Well, this portion right there, CF, times this portion right here, FB, and now we can just go ahead and plug in all our information. So let's see. Going back to this UT burnt orange, I know that EF is in fact 17.5 times, I know that FD is 5.3, and this will be equal to, of course, over here back in the teal, CF, which is 2x, times, and then FB, which is also 2x. Now, at this point, let me go ahead and just start by consolidating all my colors so I can kind of blend together one equation. And we'll say this, 17.5 times 5.3 will give us 92.75, which will be equal to, and here I know that 2x times 2x, well, we start by saying 2 times 2, which is 4, and x times x, which gives us x squared. And now we have a pretty straightforward method in solving this. We always want to get rid of our multiplication first before the exponent. So I'll divide both sides by 4, divide by 4, and I know that 92.75 divided by 4 would in fact give me 23.19. Now, of course, this would equal x squared. And you have to ask yourself at this point, how do I get rid of a square? Of course, yeah, the opposite of a square is to take the square root. And of course, what we do on the right, we have to do on the left. And it turns out that the square root of 23.19 would give us roughly 4.82. And that will equal our value of x. Now, once again, this is where a lot of students make a mistake. You stop just a little too short. we're actually trying to find CB. And notice because I have CB in this very bright teal color, I'm going to switch back to that. And I know that CB is comprised of CF, which is 2x plus, notice that 2x, FB, which is also 2x. And for both of these parentheses where the x originally was, well, we want to plug in the value of x that we found. So I'll write 2 times 4.82, and of course right there, 4.82. And let's see. The good news about these, they're both the same. So 2 times 4.82 would give us 9.64 plus, and notice how that's the same. We don't have to do the math again. We can just write 9.64, and adding 9.64 plus 9.64 will of course give us 19.28, and this will equal CB, the line that we were intending to find all along. I would encourage you to pause the video right here. And okay, now our very third example and our last example says this. We want to find the length of CB when CF, and as we see these things, let's go ahead and kind of start annotating them. So we see that CB is right there. That's the entire line. We're going to try and find that at the very end. When CF is equal to 6.3 inches, so I come over here to CF and I'll write 6.3. And we see that DF is 4.8. Okay, so I label DF right there. That will be 4.8. And lastly, we see that DE is equal to 10. Now, I think I want to use a different color to really illustrate this. But the problem with DE is that DE is actually the entire line. And so let me go ahead and say that, hey, the entire line is 10 inches. Well, this presents with us a couple problems. One, we don't know how long this part is from E to F. Okay? And two, we haven't been really given anything about FB. So here's what we want to do. The first thing I want to say is, hey, I know that this entire line is 10 inches. So I'm going to say, all right, well, 10 minus, and I know that this portion right there is 4.8. So 10 minus 4.8. And, you know, I would highly encourage you to use your calculator, especially with decimals. We'll say that 10 minus 4.8 would give us, in fact, 5.2. So it now turns out that this piece right here is 5.2. Now the second problem I said is they don't really label this with anything. And so what we want to do is we just want to go ahead and put the letter X right there because that will actually go ahead and help us out. Now just kind of referring back to our previous two examples, we now want to write our statement. And let me go ahead and switch back to this UT burnt orange. We'll say this. We'll say that the piece CF times the other piece FB is going to be equal to, now look at my other line, and since I have this in purple, let me switch back. We know that EF and then times the other section, which would be FD. Remember, when we have lines inside the circle, diameters or chords, we're always going to do the piece times a piece. Now from here I can actually go ahead and start filling things in. So let's see. We saw that CF was in fact 6.3 times, we saw that FB was where we labeled X equals, let me switch back to my purple. Here we saw that from E to F was in fact 5.2 times, and from F to D gave us 4.8. Well, now let's go ahead and start simplifying some things. So I see right here 6.3 times X would just be 6.3X. And I also see that right here, let's see, 5.2 times 4.8 would give us 24.96. And so now we want to go ahead and get the letter X by itself. So I'll divide by the number in front, 6.3 divided by 6.3. And this will, of course, give us X equals, and since I have that X right there on that burnt orange line, we'll do 24.96 divided by 6.3, and of course that will give us 3.96. Now, once again, don't let this stop you here, all right, because the question is actually asking for CB. And we notice that CB is this entire line, where this first part, CF, is 6.3 plus, and since FB is just X, well, of course, we're going to write plus 3.96. And when we add these two things, 3.96 plus 6.3, well, that's going to give us 10.26. And that will equal the entire line CB. All right. Well, I really hope that this video helped you out. What I would do is I would encourage you to go ahead and pause the video, finish the notes, and I'll see you all in our next video series.